Hello everyone, welcome back to Rare Game Official. Today we are going to discuss about scales of electronegativity. First one is Pauling scale. Electronegativity of the elements are calculated from the values of bond energies. If the values are measured in kilocalories or kilocalories per mole, the equation is Xa minus Xb equals to 0.208 under root of delta. If the values are measured in kilojoule per mole, the equation is Xa minus Xb equals to 0.1017 root of delta, where here Xa and Xb are the electronegativity of the A and B. Delta is the measure of polarity of AB bond. Delta equals to experimental bond energy minus theoretical bond energy. Delta equals to actual bond energy of EAA plus EBB. Here, hydrogen is taken as reference atom to calculate electronegativity of any other elements in the periodic table. In the periodic table, highest electronegativity is 4.0 for fluorine. Second one is Mulliken scale. According to this scale, electronegativity is the average of ionization energy and electron affinity. See, electronegativity is equals to IE plus EA divided by 2. Here, if the values are measured in electron volts, sum of ionization energy plus electronic affinity divided by 5.6. If the values are measured in kilojoule per mole, the sum of ionization energy plus electron affinity divided by 5.540. If the values are in kilocalories per mole, the equation is sum of ionization energy plus electron affinity divided by 129. Mulliken electronegativity values are approximately 2.8 times greater than Pauling electronegativity values. Mulliken scale is applicable to univalent elements. The third one is Allred-Rachov scale. This scale is considered to be real scale as it is based upon covalent radius of an atom. According to this scale, electronegativity is a force which is exerted by the nucleus on the electron. Means the attraction between nucleus and electron. Electronegativity is directly proportional to Z effective and inversely proportional to R square. Here the equation is 0.359 into Z effective divided by R square plus 0.744. Here higher the Z effective increases the electronegativity value. Here R is the radius of an element in angstrom. Z effective is the effective nuclear charge. Electronegativity is not applicable for the inert gases. In group, top to bottom electronegativity is decreases. In periods, left to right electronegativity increases. That concept already we were discussed in the earlier video. Highest electronegativity in the periodic table is 4.0 for fluorine. Cesium has least electronegativity element because highest electropositive element. Cesium has 0.7 electronegativity value. Electronegativity is used to nature of chemical bond. Electronegativity is less than 1.7, then it is said to be covalent in nature. If electronegativity is equals to 1.7, that is ionic in nature, that also 50% only. If electron negativity is greater than 1.7, that is the bond is in ionic nature. Electronegativity is used to predict the nature of the element. Means that is whether it is covalent or ionic or etc. And a tricky way to calculate electronegativity, if hydrogen and lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. If see lithium has 1 electronegativity, by increasing 0.5 to lithium electronegativity, if see by increasing 0.5, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, means fluorines already we discussed. Fluorine has highest electronegativity, that is 4.0. For sodium 0.9 electronegativity. By increasing 0.3, magnesium has 1.2, aluminum 1.5, 1.8, 2.1, 2.5, 3.0. Means if chlorine electronegativity is 3, by decreasing 0.5 it has 2.5. For sulfur, by decreasing 0.4 it will come 2.1. For hydrogen, if the value 0.4 to 0. If the value is 0 to 0.4, that is non-polar covalent bond. If the value is 0.5 to 1.7, polar covalent bond. If the value is between 1.8 to 4, that is ionic bond. If take one example, HCl. See, hydrogen 2.1 for hydrogen, 2.1 electronegativity is for hydrogen. If 2.1 is hydrogen, 3 is for chlorine, right? If subtract 2.1 from 3, that value is come 0.1. What we discuss, the 0.5 to 0.17 means that is polar covalent bond. So this is polar covalent bond. Like that we can calculate for every atom or every molecule. If observe the values, see 1.5, 2.0, 2.4, like that it is increasing from left to right. Electronegativity is increasing from left to right. If observe from top to bottom, 1, 0.9, 1.5, 1.2, it is decreasing, means electronegativity is decreasing from top to bottom. Okay, that's all for today. Thank you for watching.